Hey guys, it's Mr. Chemistry here. Today I'm going to be reviewing for this summative ionics quiz that's coming up, okay? So let's get started with the review guide. Now have your periodic table out because we're going to be referring back to it periodically. Haha. Okay, so here's level 1. Starting with simple binary ionic compounds, we're naming these formulas into their actual common names, right? The written out names. So please begin with the left side, which we have calcium. So the thing about calcium, the left side metals, or I should say cations, their names are not going to change. So bring its full name over. No matter how many there could be 2 calciums, 3, could be 100 calciums. It's still going to be just calcium. Okay. Now what's on the right side? We have chlorine. And if you go back to your notes, you should know that chlorine, when it combines into an ionic compound, its name will change into chloride. Okay, all right, that's it. It's not chloride 2, no, just chloride is all we need for this name, okay? All right, quickly, let's do another one. Here is, well, what's Li3N? Li is called lithium. And again, no name change there, even though there's 3 of that metal, right? Doesn't matter. Now, moving on to the right side, we have nitrogen. And how would that change? Nitride, okay? Now, I made a full list. I gave you the full list of all the non-metal elements that change their names. So check back to your note sheet, okay? Thank you. All right, let's move on forward. Now, let's go reverse process. How do we go from common name to its chemical formula? And that's what we're going to be working on here, okay? Start with sodium. Now, sodium, the symbol is Na. And if you look on your periodic table, it belongs to the first column, which means its ionic charge. Its ion charge is going to be +1. Okay, all right, well, that's good to know. I like writing the number first, 1 plus. Okay, what about nitride? You might think, wait, I can't find nitrate on the periodic table. Is it on the back side? No. Remember, IDE is just the conjugated name that derives from nitrogen, right? So that's simply going to be nitrogen with its ion charge 3 minus. Now take a look. If you look at these 2 ions, could they combine in 1-to-1 ratio? With having 1 nitrogen and 1 sodium cancel out the charges? No. That is why you're going to have to employ the crisscross method, right? So bring the numbers down only. Here's the 3, here's the 1. Boom. So sodium, there's going to be 3 of 1 nitrogen. Therefore, what do we have here, guys? Na3N. That's it. Let's try another one on this side. Let's try lithium bromide, okay? Lithium located on the periodic table, and you'll find that it's lithium 1 plus. Bromide, again, that's the conjugated name from bromine. It's a halogen gas. And if you look on the right side, and you'll find that it's a 1 minus. Take a look. Here's the thing. Could you combine them in a 1-to-1 ratio? Yeah, absolutely. Because if you do combine them, what charge do you end up with? 0, which is exactly what we want. So lithium, 1 Li, so 1 of it, and 1 Br. That's it, LiBr. Again, you don't have to write the ones. We just don't, okay? If you do, that's okay, but don't. All right, now let's move on to level 2, where we have transition metals. Now be very careful with transition metals, as they might have multiple charges, right? Here's one example. Iron, if you look on the periodic table, it's the 26th element, and you'll find that there's iron 2 plus or 3 plus. That's why you have to use Roman numbers, Roman numerals, to indicate which iron type that is in discussion. Does that make sense? Speaking of which, here's iron Cl2. Okay, quick thing about FeCl2 is, well, do we know which type this is? Is that going to be a 2 plus? Is that going to be a 3 plus? I don't know. We'll find out. So here's what I like to do. Take a look. How many irons do we have in this ionic compound? It seems like there's only 1 iron. So just simply write out iron with a little empty box indicating, well, I don't know what that is. That could either be 2 plus or 3 plus. And if you look on the right side, we have 2 chlorines, just like that. That I know. That I know on the periodic table. If you look, you'll find its charge, right? 1 minus and 1 minus. So take a look, guys. What charge should this empty box here be to cancel out the total of 2 minus charge I have for the chlorines? It would have to be 2 plus, so that the overall charge is 0, right, guys? So let's go ahead and name this thing. The Fe is iron. Now, using Roman numerals, since that's a 2 plus, I'm going to put down 2 as the Roman numeral, and add its name. What's the last one? What's the part on the right side? Chlorine, right? That should be conjugated to chloride. Cool? Cool. All right, let's move on forward. Let's do another question on this side. Why don't we do this one? AUF. First, you need to determine, okay, how many AUs and how many Fs do we have? It looks like it's just one of each, right? So here's what I'm going to write down. AU. Now, do I know the charge of this AU? Let's look on the periodic table. It's the 79th element, also known as gold. It's a common name. It's got multiple charges. Gold could either be 1 plus or 3 plus. Therefore, I don't know what this is, right? So let's go ahead and draw an empty box. We're going to go ahead and determine that very soon. We're going to go ahead and draw F. Okay, what's the charge on F? That I know, it's 1 minus. Okay, that was pretty simple, right? This box would absolutely have to be a 1 plus so that the charges are canceled out. Does that make sense? So which type of gold is this? Is it gold 1 plus or is it gold 3 plus? Yeah, well, we just answered it. It's gold 1 plus. Therefore, its common name is going to be gold. And what's the charge? 1. And fluorine? No, it's fluoride. That you have to change. Okay? All right, now moving on forward. Here we have polyatomic ions. Again, this is the grouping of atoms, right? Which cannot be found on the periodic, the first page, front page. You're going to have to flip over to the back page, right? And a lot of these names will end in ate or ite. That's how you should know, oh, something ends in ite, like nitrite, sulfite, or ate, like nitrate, perchlorate. And you should go, oh, I should flip it to the back side of the periodic table and locate. Okay? So please remember that as you're doing these questions. Here we go. I'm going to go ahead and try, let's see. I'm going to go ahead and try this one here. Whoa. Sorry, guys. Okay, let's go ahead and try this one here, guys. That's iron. Okay, remember how we just did a question above and we don't know which type of iron this could possibly be? Let's try this one here, okay? So take a look. How many irons do we have? Since there's not any number down here, that's a clear indication that there's only one iron. Okay, now if you refer back to your periodic table, you should know that there's 2 types, right? There's iron 2 plus or there's iron 3 plus. Okay, all right, so I'm going to leave that there for now. Let's move on over. If you look on the right side, there's a pair of parentheses here, right? NO3, guys, it's one whole thing. It's a group. Wait, how did you know that it was a grouping? How did you know that it was a polyatomic ion? Because there's parentheses around them. That should clearly tell you that, hey, remember, this is not just one singular atom, but there's a group of atoms all combined together. So if you look on the back page, NO3 is going to be called nitrate. And how many nitrates do we have? Boom, right there. 3 nitrates. Wow, that's a lot of nitrates. And if you look, what's the charge on a nitrate? It's got a charge of a 1 minus. Okay, so what should this positive be to cancel out 1 minus, 1 minus, 1 minus? 3 plus. Therefore, it would have to be this type. So naming this would be iron 3 and nitrate. Remember, you don't ever change polyatomic's name. Okay? All right, let's do one of, how about we try this one? Mercury 1 sulfate. Okay, first, locate mercury. Well, mercury is going to be Hg, and this 1 tells us that, hey, this is 1 plus. And where's sulfate? Sulfate, it ends in ATE, which means it's going to be on the back side, SO4 with a 2 minus charge. Take a look. Could I combine these two ions in 1-to-1 ratio and cancel all the charges? No, I cannot. Therefore, I need to crisscross. Bring down this 2, bring down this 1, and that's the ratio that they're going to combine in. Ready? Hg2, SO4. All right. Okay, I'm going to stop here. I hope this was helpful, and good luck studying.